Well, let's see here. In part 2, we want to take a look at some of the software we need to be able to use SPI. As you saw in part 1 of this, we looked at the hardware connections between the master and the slave. So once we get the connections done between the two, and keep in mind in this problem we want the master to just talk to the slave, so the slave will be a listener and will not reply back to the master at all. So there's a couple different ways you can run the software to make this happen. One is to, let's call this option 1 or option A. And this is where we're going to use the built-in SPI of the 328. And the steps will be this. One of the first things you'll need to do is to initialize the SPI. The code to do this is shown in the book. I won't go through all those steps there. You do this and that, and well, it's not that hard, but it's a lot of typing. But you can see it in the book in one of the examples. Suffice it to say that you initialize the SPI so it can work. The next thing you do, and it's pretty easy at this point, is you make your port B, bit number 0, equal to a low. Why this? Well, look back up above here. We said in the example that your port B, bit 0, was meant to be the port B is our slave select going to the slave. So we have to make port B, bit number 0, a low in order to select this particular slave. Once you do that, you would then do the following, which is to say SPDR, that register is equal to the letter that you want to transmit to the slave, in this case the LCD. So what I want to do for my example more specifically is to take the letter A and send it to the LCD. You put the letter A into the register called SPDR. Then at this point the 328 is doing that process. It takes a little bit of time, and we shouldn't do the next letter until that process is done. So you have to wait. And how much time do you have to wait? Well, what you do is this. You say while not, and I'll type it in here. I typed in the condition for the while, and it reads as, you look at the SPI status register, you end it with the bit pattern for the SPI flag register, you shift that number of bits over, you put a 1 there, you end it with the SPSR, and while that is not true, you keep waiting. So while that bit is a 0, while that bit is a 0, you sit there and spin and you spin and you wait for the bit to become a 1, at which point it's finished. And when you're finished, you do this. You say port B, bit 0 is a high, and this will deselect the slave, at which point we have sent the first letter, and then you can go on and send more letters if you wish. If you are sending more letters to this particular device, you don't have to deselect the device. You could just go get the next letter and then wait. But when you are finished with the entire message going to the target, you would then deselect the target. The only two lines in this example that are actual real lines of code that you would type in are the middle 2 lines that you see here with semicolons. The rest of the code that you see here is pseudocode, and it's just in English, and it describes to you what you should do. Now in the next part, we're going to do this via software implementation for the SPI.